Hello there, and welcome to chapter 12. Okay, get the microphone set here. All right, so what we're dealing with in this section is, and we talked about 12.1 yesterday in class, and 12.1 was understanding all of the pieces and vocabulary. So we learned about things like excuse me, coefficients, polynomials, monomials. What is the degree of a problem? Understanding that, we'll just take an example. 3x to the 5th minus 7x squared plus 2. Okay, we talked about that we have to understand that the degree of a polynomial is the highest exponent or sum of exponents in a term. So this would be a trinomial because it has 3 terms. These are not like terms because they don't have the same variable and exponent. So in order for you to have a like term, you not only have to have the same variable, but you have to have the same exponent. All right, so when I look at this, if I said, what is the degree of this polynomial? The degree would be 5. Well, why is it to the 5th degree? Well, it's to the 5th degree simply because the exponent is 5. It's the biggest exponent in the problem. All right, so understanding that we have to write them in order of degrees. So 5, then 2, then 1, or 0 in this case, because there's no exponent. Anything to the 0 power is the number 1. Now, these are all notes that we took on Friday in class as we started this unit. And one of the important concepts is remembering how to distribute and remembering how to add like terms. Okay, so for example, we have a very simple problem here where you have x to the 3rd minus 7x to the 5th plus 2x. And when you look at this, you should see, well, none of these are the same terms. You have x to the 3rd, x to the 5th, and x, so you can't add them. And it's not written correctly because the highest degree here is 5, so it's supposed to be in the front. You also have to keep in mind that the sign always sticks with the coefficient. So when I rewrite this, it would be negative 7x to the 5th plus x cubed plus 2x. Okay. Again, this is a trinomial. My coefficients are negative 7, 1, and 2. Okay, and it's keeping track of these things that will make life much easier. Okay, so we understand how it's written, the order in which we put it in. We know that when we're finding the highest degree, we put it in front. And then that highest degree is the degree of the polynomial. Okay. All right, so let's look at another type of problem. Let's say 3x squared minus 9. And now we're going to work on some simplification. Plus 4x squared minus 2. All right, notice this is an addition problem of 2 binomials. So now I'm just trying to add all these things together. Notice this is not multiplication. Multiplication would just have the 2 parentheses next to each other, like we had in factored form. Remember, most of you remember what factored form is. it looks similar to factor form, except there's a plus in between them. So that means we're adding whatever's here to whatever's here. So I do 3x squared. I can't add it to 2. I can't add it to 9 because the x squared is an x squared. I can add it to something else that has x squared. So what's 3x squared and 4x squared? Correct. It would be 7x squared. And then I do negative 9 plus a negative 2, which is a negative 11. All right. So I will do another type. Now this one's going to be a little bit different. I'll use the same numbers, but this time, instead of adding these two, I'm going to subtract them. Now, in the software, this has a tendency of being a little hard because the mouse is tricky and the shadowing is tricky. But the idea is making sure that this means this polynomial minus this one, which means all of these signs have to change. Correct. So the easiest way I find for doing this is when it's subtraction, changing all of the signs in the second parentheses. Okay, so for example, I would write it as 3x squared minus 9 plus, and then it's minus 4x or negative 4x squared, and plus 2. The distribution of the negative to everything in there, or adding its opposite, is the same. So now I can go ahead and do my subtraction. 3x squared minus 4x squared is negative x squared. Now it's negative 1, but we don't write the 1, it's understood. And then the negative 9 plus 2 is negative 7. And our answer ends up being negative x squared minus 7. All right, so understanding how to add like terms in a polynomial. And it doesn't matter how big the polynomial is. Sometimes they try to make it as confusing as possible. But I find it easier that as I get my problems bigger, I just start lining things up underneath that need to be done. So I'm just going to give you a ridiculously long polynomial. 3x to the 5th minus 2x to the 4th plus 3x squared minus x plus 7. Okay? Crazy. Minus 2x to the 5th plus 4x to the 4th minus x plus 2. Okay, so here's something that's really, really long. And like I said, I try to make it simpler on myself because I like to add things, and adding a negative and subtracting are the same, but if I change it all so that I understand it, it will have a tendency of making it easier. Okay, so I write out the first one because that one's not going to change. Because it's subtraction, I know that all of these signs must change. And so I don't get confused, I match them up from the beginning. So I write it out, 3x to the 5th. Minus 2x to the 4th plus 3x squared minus x plus 7. And now I'm writing the opposite of this, but I'm going to match it. So I'm going to minus 2x to the 5th. I'm going to minus 4x to the 4th. Notice I'm lining them up. Now I'm going to add x. And I'm going to minus 2. Now I have this problem nice and lined up. Why do I do this? Because now I just add straight down. 5 minus 2, or 5 plus a negative 2, or 7 plus a negative 2 is 5. Negative x plus x, they cancel out. 3x squared plus nothing, which would be 3x squared. Negative 2x to the 4th, negative 4x to the 4th, negative 6x to the 4th. 3x to the 5th minus 2x to the 5th. Remember, it's only the coefficients that change. When I'm adding and subtracting, my coefficients change. When I multiply, that's the only time the exponents will ever change. Otherwise, they always stay the same. And then I just plug in some signs, because I know it's always plus. And there's my answer. Now, you don't end up with a number answer in these cases. We're just simplifying polynomials. All right, so we're going to move on to 12.2. And in 12.2, well, I'll finish something in 12.1, but in 12.2, we're going to start talking about multiplication. And we've done this in the past. This is when we FOIL things out. Now, I'm going to do something else, and I'm going to call this g of x. Now, it's a function. I'm just calling it a name. And if I were to say, evaluate this where x equals -2, this is when you take out all of your x's, you put in a parentheses with -2 in it. So, for example, you would do this. -2 to the 5th minus 6, -2 to the 4th plus 3, 2 squared plus 5. All right, and then next is I would do my exponents. So -2 to the 5th is -2 times -2, which is 4. -2 times -2, which is 4. And -4 times 4 is 16. And then times -2 again, because it's 5 -2's that we multiply, becomes a -32. Minus 6 times -2 times -2 is 4. -2 times -2 is 4. 4 times 4 is 16. Plus 3 times -2 times -2 is 4. Plus 5. So I've done all my exponent work first. Okay, then I do my multiplication. And the last thing I do is add and subtract. Now, why do I do this and go step by step? So I keep organized, and it's accuracy. You're not trying to do it all on the calculator so you can get it done as fast as possible. That would be the wrong thing to do, and chances are you'll make a mistake. And then you'll get it wrong, not because you don't know what you're doing, it's because you do not wish to write down work. So, next would be 6 times 6 is 36, carry to 3, 6 times 1 is 6, 96. Okay, 3 times 4 is 12, plus 5. And then this last step you can do with the calculator. -32 minus 96 plus 12 plus 5, and you'll get your answer. This would be -8, 128 plus 17, which gives me -111. All right, so understanding how to plug numbers in, understanding adding like terms, that is all part of 12.1. Remember, you can pause this and rewind it and slow it down, repeat. 12.2. 12.2 is a review of the multiplication of polynomials. Okay, so I'm going to give you an example. We did x plus 7 times x minus 3. Okay, and when we do this, we FOIL. I called it the smiley face. Some people call it rainbow and smiley faces. Doesn't matter what you call it. They use area formulas to do this. They run it like a Punnett square. Most of you remember what a Punnett square is, right? So they go x and -3, x and 7. A Punnett square, right? Everybody remembers a Punnett square from Mendel's. No. Yeah, the P that you did in biology. X times x is x squared. X and 7 is 7x. X and -3 is -3x. 7 and -3 is -21. Punnett square. Now there's lots of different ways in which you can do this math. This is one of them. I'm not interested in how many ways you want to learn it. I want you to pick a way that works and do it. You have to understand what your answer is supposed to look like, and you have to understand where it began. And we go forwards and backwards in this class. We're going to multiply, and then we're going to factor. This is called factored form. So that means when we factored, it has to look in factored form. Should have some parentheses. Okay? So now you will start to understand why we learned about the forms. Now, am I done with this one? No, I'm not. In this problem, I have to then write it. Those are all my answers. So it would be x squared. Now you should know that these are like terms. So 7x minus 3x is 4x minus 21. And this is my answer. Now, this is the Punnett square. How else can you do it? You can also do it the smiley face. Remember? Here we go. This times this. I draw the line. When I draw the line, that means I've multiplied it. X times x is x squared. Notice I put it in the front. 7 times negative 3 is negative 21. Notice I put it in the back. So my eyebrows are the front and the back. Here's my nose. Plus 7x. And smiley face. Minus 3x. Okay? Notice I got the same answers, however you want to do it. And then you add your like terms. The adding of like terms and the multiplication all works out the same way. These are different visual representations of the same work. Right. And then, of course, you should get the same answer. X squared plus 4x minus 21. Okay? Now, this is done for all of your problems. One of the nice things is you should be able to make sure that your answers make sense. Okay? And we're going to do a bunch of these multiplications. Now, if you wanted to, you can use this for 2. You can use it for 3. Like I said, there are different ways to do it. Some of you are like, 3s? Yeah, well, let's just do a hard one. I'm going to make it hard. We're going to do x squared minus 3x plus 10. Okay? And then I'm going to multiply that by x plus 4. Okay? So there's my original problem. I'm going to do one way the Punnett way, one way with the lines to connect them. The idea is making sure everything connects. Now in this case, it may be easier to do the Punnett. So let's do the Punnett square. You got x squared minus 3x and 10. And then over here you'd have x and 4. So x and x squared becomes x cubed, right? Because we're putting all of our answers inside the Punnett square. And the big thing is understanding the rules. When you add, coefficients change, but when you multiply, the exponents change. So x times x squared is x cubed. X squared times 4 is 4x squared. Okay. Then we go over here, x and negative 3x is negative 3x squared. X and 10 is 10x. Then I go down here, 4 times negative 3x is negative 12x. And 4 times 10 is 40. Okay. Then I start at the corner and add the things I can. So I start here, x cubed would be written first. Then 4x squared minus 3x squared is x squared. 10x minus 12x, negative 2x, plus 40. Okay? So these are all representations. Smiley face. Same concept. We can do it, well, it's not going to be a smiley face because there's not 4 things I'm multiplying. Now there's 6. Right? So here we go. We go this way. I'm going to do x times everything over here first. So I'll do x times x squared, x cubed, x times negative 3x, which is negative 3x squared, and then x times 10, which is 10x. Right? Now I do with a 4. 4 times x squared, which would be 4x squared. Notice I go ahead and just put it underneath. 4 times negative 3, negative 12x. And then last but not least is 4 times 10, which is 40. Okay. Same concept, just drawn out a little different, and then add straight down. Okay? And I'm going to get the exact same answer. Okay? Now the only thing is I put a 1 in front of this one, whereas I didn't put a 1 in front of this one. Doesn't matter. Nah, you really don't usually write the 1. Am I going to lose my mind over it? No, I'm not. So negative 3 plus 4 is 1. 10 minus 12 is negative 2. See, double check your work. And remember, negative 2x and minus 2x are the same. And then plus 40. Alright, and that is the main idea behind 12-2. It's all multiplication and different ways of writing out multiplication problems. Alright, so now let's venture on to 12-3. And we get into some basic factoring. Now this is just like reducing fractions. This is where some of you are going to have a problem. When we factor, we're reducing factors, like reducing fractions. And when we factor, that means we're going the opposite direction. We're dividing. So now we're looking for a number to divide out of those numbers. Okay? So I'm going to make something up. If this was 12x squared minus 16x. Now, to keep yourself organized, I would do the same thing for all work. I look at my problem and I say, can I divide a letter out or take a letter out of every term? Now, I can only do it if there's a letter in every term and it's the same letter. So I will give you a problem that it works, and then I'll give you a problem that it doesn't work. In this problem, I can take an x out because there's an x squared and an x. I can take one x out. When I take the one x out, it comes out here, and everything else is then missing the x. So that means there's only one x left, and this x won't be with the number anymore because I've taken it outside. I'm reversing the distribution. I'm pulling it apart. I do the letters first. So I know when I pull the x out, that means this x squared goes to an x, and this x will be gone because I pulled it out. Then I look at the numbers. What is the biggest number that goes into 12 and 16? Hopefully you already know the biggest number is 4. Okay? Now, can I write x4? No. You want to make sure that it goes to the front. So now it's 4x. Okay, I've taken out the 4. But that means now all the numbers that would go in here are divided by 4. So 12 divided by 4 is 3x, and 16 divided by 4 is 4. I have now factored this problem, and it's in factored form. Now I'm going to throw something into you that you're going to deal with later in the week. What is this answer called then? These are called the what? Correct. These are called the zeros. Okay? Now we're going to get into this is different than the 0 we had done before. I mean, it is the same. It's the x-intercept. Okay? But the math for this is just a teeny bit different. Because normally, we know the 0 would have been at the opposite of this, which is positive 4. The problem is we're going to have to divide by 3. Because in our original problems, we just had x and a number. Now we're going to have coefficients in front of the x. But we'll get to that later. Don't worry about it. We're just worried about dividing things out. But I want you to see, oh, wait, we did something like that. Yes. Now let's look at this other problem. See, I can't take an x out of this one because not all the terms have at least one x. Now if they had 2 x's, you could take 2x out. If they had 3 x's, you could take 3 x's out. They have to have x's and it has to be the same amount. That's the big key. All right, so in this problem, there are no x's to take out. But I still can divide by what number? 4. So I pull the 4 out, and I have 3x squared minus 4x plus 1. All right? And now this is factored. That's not completely factored, but for what we're doing, it is factored. And we're going to get into depth of more types of factoring later this week. I will tell you that you will want to remember this sentence. What multiplies to blank? And then the second question is, and adds or subtracts to blank. And I'll do more explaining of this in my next video. Okay? Which goes a little bit further. Okay? Understanding what multiplies to and divides to. Okay? Alright. What multiplies to and adds or subtracts to. Now, this is a different way of factoring than what the book shows. And the only reason why we do this is because I believe in learning more than one thing and you picking which one you feel more comfortable with. You can work backwards using the table, or we can read the problem backwards. And I'll show you what I mean by read the problem backwards in class or in my next video. Right? So here we have 12.1, 12.2, 12.3 is involving the same type of things, okay? Factoring and factoring out the polynomial. We get into more in-depth and bigger numbers. That is something I want to make sure that we probably try and start in class. But factoring, the beginning of it, shouldn't be too hard. The beginning of 2.3 or 12.3. The beginning part of factoring is not too difficult. We'll get into this a little bit more in depth on my next video. Alright? Thank you very much. We'll see you at school. Go Wildcats!